So, good day, everyone. So, today we will talk about properties and operations with real numbers. So, when we talk about properties, we will talk about the different properties of real numbers and the operations of real numbers, like adding a real number, subtracting a real number, multiplying and dividing real numbers. So, in addition, I think everybody knows how to add real numbers. When we have to add the same sign, so it follows also the exact same sign. For example, a positive plus a positive, you have to follow positive sign. You have negative plus a negative, it follows a negative sign or symbol. Same as when we um, add different signs. So what should we do? Everybody knows that it follows the sign of the larger absolute value number. Okay, for example, what you should do here, you should just get the difference of the absolute value, so that is 2, and then it follows the sign or the symbol of the larger absolute value, which is 7. That is a negative, so that is a negative 2. So subtraction also in a different sense, you can also write it in these ways, like a minus b is just the same as writing it at a plus negative b. So it's just the same way, they are equal, they are equivalent to each other. So distance on a number line. So in a number line, when to find the distance between 2 points a and b, so that is just the absolute value of each of the numbers. For example, you have the a distance between a and b, so you have a minus b, get that absolute value of that. Same way, it is also equal to b minus a. Okay, for example, okay, the distance between, okay, so let's say I have 5 and, okay, let's say negative, or let's say 7. So you just have to do, okay, so have 5 minus 7, okay, get that absolute value of that, okay, and or you can have 7 minus 5. So either way you can have, or you can arrive at the same answer, which is here, that is 5 minus 7, that is negative 2. The absolute value of that is 2. So 2 units. And you have 7 minus 5, that is 2, which is absolute value of 2. So that is when we are trying to find the distance between the 2 points A and B on a number line. Okay, and another example, you have negative 8, and let's say I have 5. Okay, so to get the distance, you can either have the absolute value of negative 8 minus 5, okay, which is equal to 13. Okay, on the same way, you can also have distance is equal to the absolute value of 5 minus negative 8, which is of course also equal to 13. Okay, so 13 units in the number line. Okay, so that is how we try to get the distance between 2 points on the number line. So when the operation is multiplication or multiplying real numbers. Okay, so of course you already know that when we multiply a negative and a positive, different signs, the product or the answer is negative. And when we try to multiply the same symbol or the sign, the answer is positive. So negative and negative, positive and positive. You already know that, so I won't like really expand to that idea. Okay, so the product of even number of a negative factors is a positive. So this means that let's say you have Okay, so let's say you have -2, -2, -2, and -2. So this is a negative number, -2, and has even numbers of -2. So we have 4 to, or other say we have -2 raised to the power of, okay, -2 raised to the power of 4, which will yield us 16. So the product is 16, positive number. Okay. On the other hand, if it is a odd number of negatives, so the product will be negative for sure, and that is -8. Okay, so that is, I think everybody knows that idea where we have the add and even, okay, negative numbers. Okay, okay, let's say I have here just quickly. So let's say I have 6. So it is a even number. So we are sure that it is a positive number here. Okay, a positive answer, which is 6. So we have 64, positive 64. And on the other hand, if we have here 5 raised to the power of 5, which is an odd number, so we are sure that it is a negative answer. And that is a -32, correct? So -32. So that is how, what it means, that a product of an even number of a negative factors and the product of an odd number of a negative factors, okay, is negative, and we have here positive on the top. Okay, next. So division by 0 is undefined. So it's an imaginary number. So when we say 4 over the 0 or 4 divided by 0, it is an undefined number. And 0 over 4 is equal to 0. So remember, if you divide 0, that will be an undefined or as an imaginary number. While on the other hand, we have 0 and divided by any number that is just equal to 0. I think everybody also knows that. So in operation, we can write it in a different way. For example, we have -a over b is the same way as -a over b, and is the same as writing as a over -b. So definition of square root. So a real number, it also has one of the operation that we need to do is squaring or raising it to a power. So b squared is equal to a. Then b is the square root of a. Okay, so I think everybody also knows that when we have a square is equal to c, so that means that square root of c is equal to a. Okay, so that is now the definition of square root. The number of expression under the radical symbol. So under the radical symbols are they called radicand. So please remember that when we have like a square root of x plus 2, the radicand here is all of this are called radicand. So they are inside the radical symbol. Okay, the index of the radical. So the index is the number, and here it can be any number. So we have the square root, we have the cube root for 3, a fifth root, fourth root. So any number, this is what we call the index. So goes with the commutative property of addition. So it can be swap, so a plus b is equal to b plus a. Commutative for multiplication, so it can also be swap, like a times b is just equal to b times a. Associative, this is for the grouping. So when we group here a plus then the group of b plus c, is just the same as saying when we group A and B together, then we have C. It's just the same way as what we have on the first one. This is what we call associative for addition, associative property for addition. For multiplication is the same way. When we have the group of AB times C is just the same as A times B and C. Distributive thing. You know what this distributive is? You have A power of B or A times B, A times C. Additive identity. Anything that is added to 0 is the identity of addition. So we have 0 is the additive identity. Multiplicative identity. So that is now A times 1. So 1 is what we call the multiplicative identity. So any number multiplied by 1 is the number itself. Okay. Additive inverse. Yeah, additive inverse. You have the inverse of addition. So we have 1 over A. Okay, so you also know what the PEMDAS is. It's the order of the operation. So usually it's ordered using the parentheses, brackets, braces, radical symbol, fractional symbol. You have the absolute value. So these are the usual groupings and symbols in a particular operation. So in rational and irrational numbers, in adding this to a rational number is added to an irrational number. Let's say we have 2 plus the root of 3. So it's equal to 3.73205 and so on. Thus, we can say that rational plus irrational number is a rational number. So rational plus irrational is irrational. In multiplication is the same way. A rational number and irrational number, when multiplied together, it is just an irrational number. So the answer is an irrational number. When we multiply a rational to irrational number, the answer is irrational number. Okay, so again, one rational and one irrational, when we add them, it's still irrational. When we multiply them, it is still irrational. So the sum difference in product and quotient of two irrational numbers can be irrational and rational. So it can either be 2. So there's a lot of ways. For example, you have the square root of 3 plus square root of 3. So still it is an irrational number. Okay, but how about when we say that we have root of 3 plus, I can write it in this way, root of 3. So what do you think? So this is just equal to 0, which is a rational number. So actually you can create an example that the answer can be also a rational. It can also be a rational number in any sense. So example here, negative square root of 2 minus square root of 2. In multiplication, a rational and irrational can be rational in this sense. But how about if we have root of 6 times root of 5? So that is just equal to root of 30, which is in any case, it's irrational. Correct? It is irrational. Or we make it as an example, like smaller example, like 3 and let's say root of 2, which is root of 6. Then this is still equal to irrational. So it can either be irrational or in this case, it's rational. So how can how can it be a rational number? So let's say you have two irrational number like 6 times the root of 6. So this is just 6. So now it is now a rational number. So it can be both rational or irrational. When we multiply a rational number together, root of, let's say 2, so that is equal to root of 6, which is now irrational. So when we multiply two irrational number, it can be rational and it can also be irrational. So depending on what you do. Same as what we do in the division of irrational numbers. Okay, division of, it can be rational and in the same time it can be also irrational. Okay, so it's actually like the proof in getting or finding the value for root of x. Okay, so I think that's all for this lesson. These are the properties of real numbers and doing the operations of real numbers. Okay, once again, thank you for listening and goodbye.